about question number 3 on your homework section that you're doing. We did some of the other ones in class. This is, it's because there's a panorama of the Mississippi was 12 feet tall. So let's just get a pen here. Okay. All right, so the panorama, which is like a visual thing you walk through, of the Mississippi was 12 feet tall. So we're just going to draw the height. Then we'll say 12 feet. Okay. Tall, and it was 5,000 feet long. Okay. So the height and the length. If you wanted to make a copy similar to the original, but instead it was going to be 2 feet tall, and we don't know how long it's going to be. Okay, but we're making a copy of this proportional, and we're making a copy of it, but making it smaller, a model of it. It says, how many feet long, this one we don't know, how many feet long would the copy have to be? Okay, so let's set up our proportions, because remember, we're growing this one over here at a same proportional rate as this one is, but we're just making it smaller. So I'm going to come over here, and I'm just going to put my proportion, set up my proportions, so I'll do it in a different color. All right. So first of all, I'm going to compare, I'm going to find, okay, so we're looking for, remember we're looking when we want to make them similar, we're looking for similar sides. So we're taking this side, which is 12. I'm going to just go ahead and put that on top. And this side, which is 2. They're in the same coordinating sides, okay? Then we're going to come over here, and we're going to take this one, which is on this 5,000, so we're going to put that on top. Remember, whichever place I start, if this is a top of the fraction, if I decide to put this on the top, then this one's going to have to be on the top of the other side. Okay? Doesn't make any difference. You just got to keep it consistent. All right, so then we come over here, and this is that one, and it's going to go underneath. Now we have our proportions. Okay, so there's a couple things you can do. Once your proportions are set up, you can simplify this. You don't want to change it to a mixed number, but you can see what can divide top and bottom just to make it simpler to do your math. So I'm going to go ahead and do that. I'm going to say 2 can go into 2. I'm going to divide this by 2. Whatever I do to the bottom, I've got to do to the top. So I'm going to make it a simpler fraction. 2 goes into 12, 6. I'm going to go ahead and write it over here. Let me pick a different color. Okay, 2 goes into 12 6 times, and 2 goes into 2 1 time. And that's going to equal 5,000 over x. Okay, so let's multiply. 1 times 5,000 is 5,000. I'm going to come up and do I'm going to do it here. Since I don't have a scrap paper, I'm just trying to show you. Here we go. So one side of my equation on my butterfly is going to be this. 1 times 5,000 is 5,000. I'll go ahead and put that on this side. And 6 times something, 6 times x, is going to be on the other side. Now, just like when we were doing equations before, we set it up and we would have 6 times x equals 5,000. We have to do the inverse operation here. So if I'm multiplying 6 times x, because that's what I'm doing here, right, equals to the other side of the butterfly, 5,000 times 1, which is 5,000. Now I want to solve for x. I want to get x by itself so I know what that value is that's missing. So I'm going to go ahead. 6x equals 5,000. I'm going to go ahead and I'm going to divide by 6 to get that out of the way, just to get to x, and divide this by 6. And here again, if you want to use your calculator for this particular one, because really I want you to know the setup more so than the actual division, you can do that. If I divide 6 into 5,000, I would end up with, if you look on your calculator, you're going to end up with something like this. Whoops. 833.33. I don't know why this is glitching. So 833.33. I'm just going to go ahead and round it to 833. So x down here, the length would have to be 833 feet. That would be my answer. Okay? All right, let's look at another one. Let's look at number 4, because you're going to do 4 through the rest tonight. All right, so if you're watching this video, it says 2 tables shaped like triangles. So I'm going to go ahead and draw 2 triangles. I'm just going to put them here. 2 tables shaped like triangles. We'll just make 2 tables. 2 tables shaped like triangles are similar. That means they're the same shape but different sizes. The measure of one of the larger table's angles is 38. So we're going to go ahead and I'm just going to put an arrow. We'll make it. The measure of one of the larger table's angles, this is my larger table here, the measure of one of them is 38 degrees. So that's that angle. Okay? It's going to pick an angle. And another angle is half that size. So what's half of 38? 2 goes into 38. 19 times. So we'll just put 19 degrees over here. So let's look at it. The measure of one of the larger table's angles is 38, and another angle is half that size. So there's my half. What are the measures of all the angles of the small table? Okay, so if we know that 38, right, okay, let me go here. If we know that 38's here and 19's there, we know that when it comes to angles, similar shapes have the same angles. So I know this has got to be 38, and I know this has got to be 19. Now the only decision is it's asking us for all the angles. You have to know that in a triangle, the total degrees, if I add this angle plus this angle plus that angle, always, when you add those 3 together, equal 180 degrees total in a triangle. In a square, it's 360. That's double. In a triangle, it's 180. So if I go in, excuse me, if I go in and I say, well, I know the whole thing, this one plus this one plus this one's going to be 180, and this has got to be the same because the angles are going to be the same. This one plus this one plus this one's 180. Then I just have to add up 38 plus 19, and you can do that on your calculator really quick. So 19 plus 38 equals 57. And if I take that away from what I know the total's got to be, if I take that away from 180, it'll tell me that this angle would have to be 123 degrees. And if that angle's 123 degrees, so is this one, because they're going to have to be equal, right? The degrees are always equal. So I can always double check. If I add all 3 angles together, it should come back to 180. If not, then I know I've done something wrong with my math. And those 3, when they're added together, add to 180. So 2 things you need to know. You need to know that every triangle, when you add all 3 corners of the angles together, all 3 vertices together, it'll always equal 180. Now, they might be variants depending on how wide an angle is, but it'll always total 180. So if you know two angles, you can always add them to those 2 angles together and subtract them from 180, and you'll know the other third one. Okay, that's in geometry. But we also know if they're similar, which is what they told us here, these are similar, that if this angle's 38, its coordinating one over here is 38. If this one's 19 degrees, the coordinating one's 19 here. So if I figure out one, I can figure out for both of them. So I just added those 2 together, subtract them from 180, and it tells me the last corner vertice in my triangle is 123. So my answer would be 123. So check your answers there. We'll go over the other ones. I want you to think a little bit and walk through these, and we'll practice them a little bit more.